Let's look at the solutions of algebra. It's y minus 2 minus 1 by 6 is less than 2 by 3. Okay. So because this is a moderate term, we know y by 2 minus 1 by 6 is less than 2 by 3, or 1 by 6 minus y by 2 is less than 2 by 3, both these cases. So we get 3y minus 1 is less than 4, or 3y is less than 5, or y is less than 1.66. The other case, what do we have here? 1 minus 3y is less than 4. So 3y is greater than minus 3. Y is greater than minus 1. Okay. So now see, we have identified two limits for y. Minus 1 or 1.66. Everything has to stay within this. 4 by 3 minus 4 by 3, 5, minus 5 by 66, and 5 by 6. This lies within this range. Minus 5 by 66 lies within this range. Minus 4 by 3, does it lie within this range? No, not really. Minus 4 by 3 will go to the extreme. 4 by 3 does lie within this range. So the answer to the question has to be option A. Next, a function fx is defined as fx is equal to x cube minus px square minus q square x minus 6r, such that fp is equal to fq is equal to fr is equal to 0 and r is equal to 6. Then find the value of f2. Simply see, if fp is equal to fq is equal to fr is equal to 0, basically p, q, r are roots of this expression. P, q, r are roots of this expression. Now sum of roots is given by the negative coefficient of the second highest power. So if the three roots are p, q, and r, p plus q plus r is equal to p according to the expression here, which would mean p and p get cancelled. So q is equal to minus r. I already know r is 6. So q has to be minus 6. That is also identified. And now when q equal to minus 6 is identified, now see 6r is equal to p into q into r, product of roots, negative coefficient, yes. So I've got 6 into 6 is equal to p into minus 6 into 6, cancel, cancel, p is equal to minus 1. So now we have the entire expression available to us. Fx is equal to x cube minus minus 1, so plus x minus q squared, so minus 36x minus 36. This is the entire expression. Let's replace 2 in here. I get 8 plus 2 minus 72 minus, sorry, this is not x squared. So 8 plus 4 minus 72 minus 36. So final answer you get is option B, minus 96. Next, an infinite sequence is defined as Tn plus 1 is equal to Tn into R, where Tn is the nth term of the sequence. If T2 is equal to 4 and all the terms are positive, then the sum of the infinite terms should be at least. Okay. If we are looking for it to be at least, clearly this is a G2. If we are looking for it to be at least, and this is an infinite terms, then how do I operate it? Okay, if let's say the terms in the series are ar squared, ar cubed, we have been told this is equal to 4. Ar is equal to 4. So can I go ahead and say A is equal to 4 by r? And sum of an infinite GP is given by A divided, sorry, first term divided by 1 minus r. Now I know A to be 4 by r and 1 minus r. If I want this expression to be minimized, if I want this sum to be minimized, I need this denominator to be maximized because the numerator is fixed. I need this denominator to be maximized. Maximization would happen on at one of the extremes. Either r is equal to 0 or r is equal to half, because 1 and 1 minus r would become equal at half. So at 0, of course, you can see this will turn to infinity sum. We don't want that. So we want r equal to half. So we get 4 by half into half, or we get r sum as 16. Minimum possible sum of all the infinite terms should be 16. Next, if a, b, c are positive real numbers and a plus b plus c is equal to 9, which of the following cannot be the value of a, b, c by a, b plus b, c plus c? Okay. One thing, let us look at two extremes again. If I took a as 9, b as 0, c as 0, although it says positive real numbers, I'm taking it as 8.9999999999999 and b as 0.00 like that, and c also 0.00 like that. Positive real numbers I'm not really bothered by. So in that case, this expression will return a value of 0 because the numerator will turn to 0. Oh, the value returned would be, yeah, numerator will turn to roughly 0. Done. On the other hand, if I took these three variables to be as close as possible, I took them to be 333, then I would get 27 divided by 9 plus 9 plus 9, 27 again, so 1. So for this expression, I know the values will lie in the range 0 to 1. Lies in that range, lies in that range, lies in that range, does not lie in that range. So this is our final answer. You cannot reach 4 by 3. With this expression, you cannot reach 4 by 3. Okay, what is the area bounded in square units by the graphs of the function x mod minus y mod is equal to 1 and y mod is equal to 1? Okay, first let me draw a graph for y mod is equal to 1. It will go something like this. Y equal to 1, y equal to minus 1. Now x mod minus y mod is equal to 1. Okay, see, instead of memorizing how these graphs look, simply put in the values of x is 0. Can you get 1? Never. So x would have to be 1, then y would be 0. Or even if x was minus 1, y would be 0. Can I say I've identified 2 points? 1, 0 and minus 1, 0. Now, if I took x to be 2, y could be 1 or minus 1. So at x 2, y could be 1 or minus 1. So you see, these lines have been identified. Similarly, if x was minus 2, y could be 1 or minus 1. These lines have also been identified. We are only supposed to look for the area bounded by these graphs. So this is the area we are seeking. This is the area we are seeking. And joining these lines, joining these points, if you want, the coordinates of these points would be very easily identifiable. It is 2, 1, 2, minus 1, minus 2, minus 1, minus 2, 1. Can you see? If I can use a different color, it would be easier. This, using these 4 vertices, the rectangle that is getting created, this side is 4, this side is 2. So area of the rectangle is 8. But from this rectangle, we have to remove these 2 triangles. And for these 2 triangles, can you see? This length here is 2. The height here, the altitude here is 1. So area of both of these triangles is 1. Area for both of these triangles is 1. So from 8, you have to remove 2 altogether, and you reach your final answer 6. The answer to the question is, of course, C. I hope you learned something. That will be all for this episode. Okay, bye.